It depends on temperature or pressure or only temperature. So remember that we have done long back. UIG, function of temperature. HIG, function of temperature. SIG, function of temperature volume. Similarly, GIG, function of temperature. All those things you have to remember. If you don't remember, I cannot teach thermodynamics. Okay, so what will happen? This is that delta mu, delta GI. So mu I Ig, we have TPX bar minus mu I Ig TPSS. That is your delta GI Ig. Correct? Which is nothing but delta HI Ig minus T delta SI Ig. This delta HI Ig is function of temperature only. So pressure will not affect. Then you have to remember everything. I was thinking that you will be prompting me, I will be writing. I am only writing and prompting. T delta SIG. What is that? But temperature is constant, only pressure is changing. So what will be delta SIG? You have done long back. Please go back to your customs. If you have that. SIG. Delta SIG. Temperature is constant. What's the expression? Delta SIG. This temperature is constant, only pressure is changing. P to PSS. P to PSS. What's the expression? What's the expression? DS is there, no? S is function of P and Q. I have done all those things in the class. SIG. Yes. Did you get, madam? How can I teach thermodynamics advanced topics? The simple things what I have done long back. We are just struggling. When the temperature SIG is a function of temperature pressure, you have to do DS. Minus R by P. You are just guessing, right? Please don't do that. Try to feel it what you are talking about. Try to feel it, how it is coming. DS. How DS comes. Now I have to go more fundamental. I don't know what I am doing in the class. And after this course, you will forget it. I know. I am doing my duty. DS equal to S is a function of S at TP. DS is dou S dou P at P dt plus dou S dou P at P dP IG. All those things I did in the class. I am sweating out. That time also I sweated out. It went to drain. Excellent. No problem. Now can you tell me? Or again you need something from me. What is dou SIG by dou P? And in our case this is 0. Temperature is constant. At least tell dou SIG by dou P at T. It was done earlier. Right? What is that? What is that? Dou SIG by dou P? Minus R by P dP. So what will be dou S P to PSS? Tell me the answer. What is that? Minus R ln PSS by P. So what will be by GIG? TP. Delta. This subtraction. What will be minus T delta SIG? Plus RT. It is correct what I am saying. So much I have to do, right, for this. That's what if you don't understand the basics, that's what I'm all the time talking about. If you don't feel thermodynamics, It is not that it will mug, it will come fundamental ways. If you mug it up, you cannot tell me. So what should I write here? Here this term. That's what it is arbitrary term. Sometimes say P, then ln P. If I say like in the class, I will do P. Ln P by PSS. Sorry. FIM by PSS. So activity of the mixture, you got Fi mixture by PSS, first case. Activity for the first case you got very simple expression FIM by PSS. Second expression pure component. Second expression pure component. Pure component I AIM exponential mu IM minus mu ISS by RT. This can be written as exponential mu IM minus mu I TPSS by RT. This is not mu I IG, mu I TPSS, pure component. I can have IG, you can have pure component. You can write this as mu IM minus mu I IGM. Now what will be the next? Plus mu I IGM, no problem. Next. Mu I, can you solve it? What can you get? Mu I IGM and mu I IG relationship is there. But in pure substance, can you have the relationship? You have to get some derivation, no? Some kind of formula. I have done this kind of things earlier. I have done it. This is not the first time I am doing it. I have done the gas mixture. It comes from gas mixture. Gas mixture only the reactive system. That's all. Everything else is same. What are the next terms? Mu IGM is there. IGM, I know that. Mixture to ideal gas mixture to ideal gas to the pure component. That's the way actually you do that. I have done it earlier. Mixture, ideal gas mixture, then IG. If up to IG is okay. If it is not IG, then pure substance. Minus mu IG plus mu IG minus mu I TPSS by what did you get first term? Fy by Pxi, right? Second term. There will be three terms, right? Second set will be what? Exponential mu I IGM minus mu I IG by RT. Third term. Exponential mu I IG minus mu I TPSS by RT. This you got RT and XI. RT will get cancelled, you get XI. Fi by Pxi into Xi into. What is this term? Remember that this pure component. If you want, you can write mu I pure, no problem. You don't write it. The pure component. The best thing to write mu I star. That's what we are following. Mu I star. If you follow mu I star, it's good. Star denotes pure component. Otherwise, you say some quantity component, then you are lost. The pure component. How do you define this term? Pardon? X term. FI star by P. At least you told me, thank you very much. But what is the term? It is mu I Ig minus mu I star. But then what will be the term here? P by Fi star. So two kind of models you got. First case you got FIM by P SS. Second case you got Fi by Fi star. Fi mixture by Fi star. Okay, these two things are clear. Okay, fine. Now we go back to our equilibrium constant based on activity model ln K, which is minus RT summation summation mu y gamma, right? So let's look at equilibrium ln Ka equals to minus 1 by RT summation I equals to 1 to C gamma I mu I SS. You can write also minus 1 by RT summation I equals to 1 to C gamma I mu I SS T E SS. Quite often we talk about d ln K by dt. The function of temperature, you can see that. This ln K is a function of temperature and pressure, mole fraction. So you can always take derivative d ln K dt. Which should be what? dt means term is here, temperature is here, temperature is here. There are two terms. So first, like ddx of UV, one temperature is coming in RT, denominator, another temperature is coming in mu I. So what will be my final term? There will be two terms. What will be my final terms? What will be my final term? There are two terms, right? If I say 1 by RT square, what are the two terms? Summation I equals to 1 to C
gamma mu I SS minus summation
minus
gamma I T.
what is that? Gamma I?
Gamma I temperature.
Temperature will be coming outside the summation.
Summation gamma I dou mu I SS by
Not dou, d. Okay. So now we'll see with two standard states. We'll see with two standard states. We'll see this with two standard states. So one is mu I SS equals to mu I Ig Tp SS, which is SS1, first standard set. Ka SS1 equals to pi I equals to 1 to C What should I write here? First standard state AIM is there in his book. Pardon? Yes, Fi mix by PSS gamma I. Then we have defined Kp. We have defined Kc. We can also define in terms of Kf, in terms of fugacity based equilibrium constant. So if you define in terms of fugacity based, what formula you get? In terms of fugacity based, equilibrium constant. In terms of fugacity based equilibrium constant, what should we write? In terms of fugacity based equilibrium constant. In terms of fugacity based equilibrium constant, what should we write? Pardon? Kf divided by PSS raised to okay. So it is nothing but this term is coming as FIM gamma 1, FIM gamma 2 and so on divided by PSS to the power gamma 1, PSS to the power gamma 2 and so on. Am I correct? So this term is coming like this term. So this up term we can write as I equals to 1 to C FIM to the power gamma I, and this we can write as PSS to the power summation gamma. Okay. This analogous relationship, it will be nothing but Kf. This is the sigma gamma I. What is that? I equals to 1 to C. Gamma product 1 plus gamma product 2 minus gamma reactant 1 minus gamma reactant 2. So it should be written as delta gamma. For our case, C plus D minus A minus B. Delta gamma. So you can write PSS to the power delta gamma. Yes. So what is, so we got KSS1, so what is LNKA for this case? Is minus 1 by RT summation I equals to 1 to C gamma I GI TP SS, you can write mu I also. What should I write here? We have written something like delta gamma. Can you write something here? ln K if you say it is first steady state, no problem. What should you write? This in terms of like this, something you can write. What is this one? Nu1 G1 EP SS1. Sorry, gamma 2 G2 EP SS2 and so on. This product is positive, positive, gamma 2 negative, gamma 4 negative. Again you can write delta G, this one. You can write minus 1 by RT delta G EP not clear? Not clear. What is heat of reaction delta H? What is? How to calculate? Let's see. You have done chemical reaction here. We have the enthalpy given for this. How to write delta H? Product minus. So C into this plus D into this minus A into enthalpy minus B into enthalpy. If the Gibbs penalty is given, how to calculate? C into this delta G, C into the G, D into that minus this. That's why I wrote no here. This all comes from fundamentals. Okay. So it says Ka equals to Kf PSS1 to the power minus gamma. Also you can write this as exponential minus delta G SS1 by R. Agreed? We got first K equals to K PSS1 to the power minus delta gamma. The same thing, the same way, you can write as exponential minus delta G SS1 by R. So now d ln K by dt. The first steady state which is d ln K by dt. What did you get? D ln Ka by dt based on the first steady state 1 by RT square. You get here, you write properly nu I Gi SS1 minus T to summation I equals to 1 to C gamma I D Gi Ig EP SS1 x bar why Ig? Because first steady state based on Ig, right? Second steady state based on the pure substance. Okay. One by RT square. This will write what? This will write what? We have just discussed just now. Gamma summation gamma Gi SS1 is what? Delta G SS1. Next term, dou G Ig by dou T at constant pressure. What will happen? Dou G Ig by dou T. This term will be what? GIG is nothing but GIGT. GIG is nothing but dou GIG dou PT plus dou GIG dou PT. Temperature is constant. Sorry, temperature is changing, pressure is constant. What should you write? This down. We have done earlier, very beginning. Dou GIG by dou T at fixed rate is constant. The dP will be 0. Okay, so yeah, dP will be 0. What will you get? What is that? Minus S. So what you can write? Minus T or plus summation I equals to 1 to C mu I SIIG T P X bar. What should I write here? Summation mu I SIIG is delta S. So you got 1 by RT square delta G SS1 plus T delta S. What is nothing but delta H. G equals to H minus TH. H equals to G plus TH. Delta H is, so that means dln Ka by dt, dln Ka by dt, we can write this as 1 by RT square delta H SS1. And how to calculate? You know that, how to calculate. We have the standard enthalpies for all the reactors. If I supply it, you calculate enthalpy change, and with that you can say that if you know the temperature R, we can say this is the way my equilibrium constant would vary with temperature if I have first standard state. Yes. Was this familiar to you earlier? Did you study all those chemical reaction equilibrium? Is it the first time you are learning chemical reaction equilibrium? Earlier you have done, right? What's the difference? Derivation. No? Derivation. You didn't have any derivation earlier. Okay, so this part is clear. So from here one can have ln KT2 by KT1, the function, which is, if I want to have ln KT2 by KT1, what is the right hand side? What is the right hand side? Tell me.
SS by R.
Delta H SS1 by R.
1 by 2.
This equation you have seen earlier. But this is a derivation. We used to assume this equation, right? That, see, to come to this, I have to spend so much of struggle and so much of, and that is based on the first instant. It's based on the first instant. So coming back, dln K by dt SS1, which is 1 by RT square delta H SS1, which also, and go back what we have done earlier, summation I equals to 1 to C nu I HI TP SS1 HIIG, right? So this HIIG is generally given for any of the books. That's the advantage. That's why we actually take SS1. That's the advantage. Why we take SS1? Because any books, Paris Chemical Engineering Handbook, everywhere you can get ideal gas enthalpy. So if it is given, that means it's better. So you can actually get the table from the table. You can calculate dln by dt. So HIIG TPSS may be expressed as a function of T. And you know that dou H by dou Tp equals to Cp. Ig means Cp Ig. So delta H is nothing but T0 to T CPIG dt. You can easily calculate. So CPIG generally given as a function of temperature also. So delta H I Ig is nothing but T0 to T CPIG dt, right? Because the function of temperature. YBC Rao's book and then Sandler's book, you see the list of CPIG. The form is A plus BT plus CT square plus ET to the power minus 2 dt cube plus e to the minus 2. So there are 5 coefficients. The function of temperature is treated, it is like that, A plus BT plus CT square plus dt cube plus ET to the power minus 2. A, B, C, D, E are given in YBC Rao and Sandler for various components like hydrogen, oxygen, carbon, all the cases. Okay, so let me write the form of CPIG. So CPIG T AI you can say for component plus DITQ plus EI to the power minus 2. So this component, how should I write? I equals to 1 to C gamma I HIIG TPSS. We have to calculate. And that will be equals to so you can see from here delta HIG. Delta HIG means HIG T0 minus or HIG T minus HIG T0, right? So you can write this as gamma I HIIG T0 PSS plus I summation I equals to C gamma I, then fill in the blanks. This formula is given. If you want, I can put I here, no problem. This is what? This is HIIG T minus HIIG T0. So HIIG is HIIG T0 plus something. What will be that? Tell me the answer. You know what I have done? Very simple. What is the term? Yes. What is that? Integral T0 to T CPIIG then T prime dt. Correct? So, for a reaction, this is nothing but delta H reaction, TPSS. We have done our long back, right? How to do it, you know that. Delta H is heat of reaction. Product will be having positive sign, reactant will have a negative sign, this will be in delta H. Right? This will give what? Delta H reaction at T0 PSS. Correct? This is actually IG, or you can say SS1, no problem. If you want, you can put IG or you can put SS1. Interesting term is this. What will be the term? CPIG formula is given. AI plus BIT plus CIT square plus DIT cube plus EI e to the power minus 2. Please write in terms of delta. Plus is given already. Yeah, you know the answer? Integral won't come because we have to integrate, right? Why integral is coming? Because I have given the formula, no? Yeah, just don't guess. Tell me the terms, first term. How many terms will be there if you integrate? 1, 2, 3, 4, 5. First term. Delta A, not delta A, P minus plus delta B by 2 T square minus T0 square plus delta C by 3 T cube minus T0 cube plus delta D by 4 T to the power 4 minus T0 to the power 4 minus delta E 1 by T minus 1 by T0. So that's the heat of reaction. Heat of reaction at particular temperature. SS1 generally we get at T0, which is standard state temperature, 25 degrees centigrade. 25 degrees centigrade. Pressure into atmospheric pressure. That's the way it has been supplied. But we have some other temperature. Okay? So this is the formula we have to follow. So delta H reaction, particular temperature, pressure steady state is nothing but delta H reaction. SS1 delta A is T minus T0, delta B by 2 T square minus T0 square plus delta C by 3 T cube minus T0 cube, delta T by 4 and so on. And delta A equals to, for your reference, you can write delta A is summation gamma IAI, delta B is summation gamma IBI, delta C is summation gamma SCI, delta T is summation gamma IBI, delta E is summation gamma IBI. So, coming back here, ln K d by dt, which is 1 by RT square, delta H reaction SS1 T. So now you can see ln K T2 by Ka T1. We cannot write simply like this because it is assumed delta H was constant. Now delta is a function of temperature. We cannot write like this. So now you can see that this is valid if delta H is constant. If delta is a function of temperature, then we have to write this as T0 to T delta H reaction SS1 T prime by T prime square dt prime. So there are two relationships. One is this, another is this one. This relationship, this is constant heat of reaction. Here the heat of reaction, the function of temperature. So equilibrium was a function of temperature, and this is related to the heat of reaction. Okay. Have you heard about Hess's law? Okay. So please read into that part. And Hess's law actually what I was talking about, how to calculate the heat of reaction. And so basically you have to know the formation reaction, and based on that you can calculate the heat of reaction. So that's called Hess's law that we will talk in the next class, and then we will take the example problem. Thanks for paying attention. Monday is next class, right?